Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video explains how to construct confidence intervals for two population proportions. Let's get started. So a lot of the menu options that we've seen for hypothesis testing are very similar between one sample and two sample hypothesis testing. So no surprise, you should be expecting this. A lot of the menu options for the two sample confidence intervals in StatCrunch are going to be the same as what we saw with the one sample. The big difference is that we're going to select two sample instead of one sample. In our options window, notice that we've got places to put proportions for the first and second sample. What we learned from the hypothesis testing is going to be pretty much the same. The sample that's mentioned first is going to be sample 1. The one that's mentioned second is going to be sample 2. We click the radio button down here for confidence interval, but take note that your confidence level is no longer just 1 minus alpha. Now that you've got two populations that you're comparing, your confidence level will be 1 minus 2 alpha. Very important difference to keep that in mind. So if you put in the wrong confidence level, of course, the limits that you get, the upper and lower bounds for your confidence interval, are going to be incorrect. So in this particular example, we're putting in a 95% confidence level because our alpha is 2.5%. So 0.025 times 2 is 5%, subtracted from 1 is 95%. So again, you must remember that when you're constructing that confidence interval for two samples, the confidence level is 1 minus 2 alpha. And then when we press compute, we get our results, and we just take those right off the results window just like we did before. The upper and lower limits there are at the end of your results table. Let's look at the previous problem we were looking at with Echinacea and construct the appropriate confidence interval. You get this question quite a bit in your assignment. They don't tell you what the confidence level is because they want to test your ability to remember, hey, it's 1 minus 2 alpha and not just alpha, 1 minus alpha. So they'll say appropriate confidence interval. Once in a while, you'll get a problem statement that actually specifies the confidence level to use. And in those instances, they're few and far between, but they do exist. If it's specified, you want to go ahead and use what's specified. But if they say appropriate confidence interval, then you've got to use 1 minus 2 alpha. So here's our options window in StatCrunch. Notice how we put in the same sample information that we did previously for the hypothesis testing. The Echinacea group was mentioned first, so it's sample 1. The treatment group is mentioned second, so it's sample 2. And then look down here at our confidence level, and you can see that we're calculating 1 minus 2 alpha. Our alpha listed in the problem statement is 5%. So we're not going to use 95% for a confidence level. We're going to use 90%, 1 minus 2 alpha. Then in the results window, we get the upper and lower limits. So they're on the end of our results. So we can just construct our confidence interval as we see here. What do we conclude from these results? Well, typically, when you're looking at the difference of two population parameters, you're going to be asking yourself, is 0 inside or outside my confidence limit? Inside the confidence limit that we see here means that 0 could be the value, and that means there's no difference between the two populations. So, because 0 is contained within the bounds for this confidence interval here, then that means the difference between the two proportions could be 0. And if the difference is 0, then that means the proportions are the same, which means the Echinacea has no statistically significant effect on, those who are treated for, developing the common cold virus. Now, again, I have that friend from college, and I can still, hear her in my head swearing from what her mother told her that it works. And, there's that old wives' tale about echinacea, but in this particular study, you see that it didn't make much of a difference. Now, keep in mind, you've got 45 subjects in the treatment group and 103 subjects in the placebo group. It's not exactly a huge sample size that you're dealing with. So perhaps if you were to take a larger sample, you could get a different result coming out of this. But as it is, these are the results that we get from the samples that we have. Remember, when you're dealing with proportions, sometimes the CI gives you a different result than the hypothesis test. So when it comes to making formal conclusions about, different proportions, you want to rely on the hypothesis test and not the CI itself. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.